Time has always been among the greatest enigmas of existence. Invisible, intangible, and yet absolutely indispensable, it is the line upon which everything we know unfolds. From the instant the universe came into being more than 13 billion years ago, to the present second in which you hear this narration, time has never ceased to act. But does it truly exist? Or is it merely a creation of the human mind to understand the sequence of events? This question, which crosses the history of philosophy and science, may reveal not only the nature of the universe, but also the essence of what it means to exist. Most of us intuitively believe that time is something real, flowing in a continuous direction from past to future, dragging everything along with it. We measure this flow with clocks, calendars, and equations. However, when physicists and philosophers attempt to define what it truly is, discomfort arises. No one can describe it completely. It is not a substance, not energy, not a force, and paradoxically, it cannot be directly observed. Time reveals itself only through its effects, through the movement of bodies, the transformation of matter, and the change of states. In classical physics, time was seen as something absolute, independent of everything else, like a fixed background where events unfolded. But this idea began to crumble at the beginning of the 20th century, when Albert Einstein showed that time is not universal. It depends on speed and gravity. This meant that there is no single now for the entire universe, and that time can run more slowly for some observers than for others. Time, therefore, is not the stage, but part of the plot itself. Even before modern science, philosophy already suspected the illusory nature of time. St. Augustine, for example, said that he knew what time was, until someone asked him to explain it. The Greek thinkers, on the other hand, saw time as a cycle, something that does not run forward but returns upon itself, like the seasons and the movement of the stars. This circular view contrasts with the modern idea of a linear time that begins with the Big Bang and ends perhaps in the thermal death of the cosmos. Time is also the thread that stitches together human experience. Without it, there would be no memory, no expectation, no learning. The human brain, in order to interpret reality, must divide the continuous flow of events into past, present, and future, creating the illusion of sequence. But the universe, in its most fundamental form, may not recognize these boundaries. What we call the present may be only a limited slice of the totality of a greater space-time, where everything already exists simultaneously. This is the core of the mystery. If time is real, it must exist independently of human perception. But if it is a mental construct, then perhaps the universe is timeless, a great static block where nothing truly happens, and motion is only an illusion of consciousness moving through that block. Modern physics and philosophy intertwine in this doubt, and what we have discovered over the last few decades is that both answers may be right and wrong at the same time. With every passing second, the entropy of the universe increases, giving the impression that time has a direction. Yet the fundamental laws of nature, such as the equations of quantum mechanics and relativity, do not distinguish between past and future. They work equally in both directions. This means that, at the deepest level, time does not flow. It simply is. What moves is our consciousness, which experiences a sequence of states and calls it the passage of time. Thus the question remains, is time the engine of the universe or merely the reflection of something deeper? Could it be an emergent property like temperature or pressure, which arises only when there are observers and complex systems? Or could it be a fundamental dimension, as real as the space we occupy? The answer to these questions redefines not only physics, but the very notion of existence itself. And as we strive to understand it, time, whether real or not, continues to pass relentless through our lives. Long before science tried to decipher time, human beings learned to feel it. Time was born, for us, not as an equation, but as a sensation. It was born from sunrise and sunset, from the cycle of harvests, tides, and the phases of the moon. Each change in nature told a story, and humankind, by observing the sky, learned to turn chaos into rhythm. Thus came the first measures of time, not through machines but through observation. Time was the very breath of the earth. Ancient civilizations became masters in the art of measuring the invisible. The Egyptians counted days by the flooding of the Nile and erected obelisks to mark the passage of the sun. The Babylonians recorded the movement of the stars and divided the celestial circle into 360 degrees, creating the foundation of the sexagesimal system that we still use to measure hours and minutes. The Mayans and the Aztecs, in turn, saw time as a cosmic cycle, where each era ended in destruction and rebirth. For them, time was not linear, but sacred, an eternal flow of death and recreation. The ancient Greeks, on the other hand, gave time two faces, Chronos and Kairos. Chronos was chronological time, the one that passes and ages. Kairos was the opportune moment, the time to act, the subjective time that exists only within consciousness. This distinction between physical time and lived time reveals a profound intuition. Time is not only something we measure, but something we feel. As civilization advanced, time began to be tamed. The invention of sundials and clepsydras, the water clocks, marked the beginning of precise counting. But it was the mechanical clock, at the end of the Middle Ages, that completely transformed humanity's relationship with time. For the first time, time ceased to depend on nature and came to be controlled by the machine. Hours began to have the same length everywhere, and life began to revolve around the regularity of the hands. Time became a tool of power, a symbol of discipline, productivity, and social control. However, something was lost in that process. When time was reduced to numbers, it ceased to be an experience and became a tyranny. Industrialization intensified this change. The worker began to sell his time as a commodity, and modern society began to measure the value of life in minutes and deadlines. Time, which had once been a natural cycle, became a rigid line that moves forward and never returns. But the time of nature never obeyed the clocks. The heart beats to its own rhythms. Plants grow in silence. The planet turns with a majestic slowness that ignores the ticking of hands. Even scientists, when observing the cosmos, realize that each region of the universe has its own time. The Earth revolves around the Sun orbits the center of the galaxy, and each system on its scale lives its own rhythm. In philosophy, time has always been a mirror of the human mind. For Aristotle, it was the measure of movement according to before and after. For St. Augustine, time existed only within the soul, the past in memories, the future in expectations, and the present as the only real instant. For Immanuel Kant, time was a form of perception, a lens through which we organize reality. It was not out there, but in here. Each culture, each era, and each human being, therefore, lives time in a distinct way. Nomadic peoples see it as repetition, modern societies as a race, mystics as eternity, and perhaps none of these visions are wrong. Time is simultaneously biological, psychological, physical, and symbolic. It is both the ticking of an atomic clock and the sensation of a second that never ends when we await something important. In the end, to understand time is to understand ourselves, for time is not only what passes, it is what transforms us. It teaches us finitude, memory, urgency, and the value of existence. The history of time is also the history of consciousness. For centuries, time was considered a simple and unquestionable truth. To the scientists of the classical era, time was like a constant and invisible river, flowing from the past toward the future, continuously and uniformly in every corner of the universe. This view gained strength through the thinking of Isaac Newton in the 17th century, when he proposed that time was absolute, an entity independent of everything else, running at the same pace whether there was motion or rest, whether anyone observed it or not. For Newton, time was a static and eternal dimension, a stage upon which events unfolded, but which was never affected by what happened upon it. This notion of absolute time worked perfectly to describe the everyday world. Newton's laws accurately explained the motion of the planets, the falling of apples, and the operation of machines. In this model, the universe was comparable to a gigantic cosmic clock, perfect, predictable, and mathematical. If we knew all the positions and velocities of the particles at a given instant, we could predict the future and reconstruct the past with precision. That was the dream of Newtonian determinism, a cosmos completely governed by fixed laws, where time merely watched, indifferent, as causes and effects played out. However, this idea carried a silent contradiction. If time was absolute and immutable, what made it different from space? Newton saw time as something running apart from the three spatial dimensions. It was not part of matter, energy, or gravity. It was merely the backdrop. This conception implied that the entire universe shared the same now, that the present was universal and simultaneous everywhere. Yet this assumption, though intuitive, was never proven. It was a convenient belief, not an observable fact. Even so, absolute time was the foundation of classical physics for more than 200 years. This vision shaped science, philosophy, and even the way humanity came to see itself. Time seemed stable, predictable, and reliable, an invisible clock that never lagged. It was believed that everything in existence followed the same rhythm, from the motion of the stars to the beating of the heart. That stability upheld the idea of an ordered and rational universe, created according to unchanging laws. But as the 19th century progressed, cracks began to appear. New discoveries in light, electricity, and magnetism showed that nature did not always obey the same rhythm. The Scottish physicist James Clerk Maxwell demonstrated that light had a constant speed, independent of the motion of the observer. This meant that something was wrong with the concept of universal time. If time were truly the same everywhere, light should vary according to the observer's movement, but it did not. Time, therefore, could not be as absolute as once believed. From that moment, the foundation of Newtonian time began to crumble. The 20th century was approaching, and with it a new revolution was about to completely transform our understanding of the universe. A young patent clerk in Switzerland named Albert Einstein would challenge everything humanity thought it knew about space and time. He would prove that time was not a constant, but a variable, that it could stretch, contract, slow down, and even almost stop, depending on speed and gravity. Time would cease to be a stage and would become an active character in the cosmic drama. The transition between classical physics and relativistic physics was one of the greatest intellectual revolutions in history. For the first time, time ceased to be a fixed line and became a malleable dimension. And with that, the notions of past, present, and future would gain a new meaning, one that still challenges our perception and our deepest intuition to this day. The 20th century began with a seismic shock to human thought. A young man with a calm gaze and a restless mind, Albert Einstein, would rewrite the laws of the universe and forever change the way we understand time. In the year 1905, at just 26 years old, he presented to the world the theory of special relativity, a work that utterly destroyed the concept of absolute time, defended by Isaac Newton and sustained by classical physics for more than 2 centuries. Einstein showed that time is not a universal constant, but a relative phenomenon. It depends on the velocity of the observer. This means that two identical clocks, placed in different locations or moving at different speeds, do not measure the same interval of time. Time, which once seemed to be the unshakable foundation of reality, revealed itself to be something flexible, elastic, almost alive. This discovery was not merely mathematical, it was philosophical. For the first time, time ceased to be the same for everyone. Special relativity was based on 2 simple premises. The laws of physics are the same for all observers moving at constant velocity, and the speed of light is the same for everyone, regardless of how fast they move. From these ideas, Einstein realized something astonishing. Space and time did not exist separately, but were intertwined in a single entity, space-time. What one observer calls distance, another may call duration. What is simultaneous for one may not be for another. The present, therefore, is not the same everywhere in the universe. The consequence of this discovery was profound. Imagine 2 twin brothers. One remains on Earth, while the other travels through space aboard a ship, moving close to the speed of light. When the traveler returns, he discovers that he has aged less than the brother who stayed behind. This phenomenon is called time dilation, and it is not science fiction, it is proven reality. Experiments with subatomic particles, atomic clocks aboard planes and satellites have shown that time truly slows down as velocity increases. However, special relativity still treated time in contexts without gravity. 10 years later, Einstein took an even greater step. In the year 1915, he presented the theory of general relativity, in which time not only dilates with velocity, but also curves in the presence of gravity. In this new model, gravity was no longer an invisible force pulling on bodies, but the result of the curvature of space-time caused by the presence of mass and energy. The more massive a body, the more it deforms the fabric of space-time around it. And the greater this curvature, the more slowly time passes. This idea seemed absurd at the time, but it was soon confirmed by observation. Clocks placed at different altitudes, for example, mark different times. Time runs more slowly on the surface of the Earth, where gravity is stronger, than on mountains or satellites in orbit. This is why global positioning systems, which depend on extreme precision, must correct these differences in time to function correctly. Time is literally shaped by gravity. With Einstein, the universe ceased to be a machine and became a living fabric in constant deformation. Space and time, which once seemed like separate entities, became inseparable. Reality is not made of 3 spatial dimensions and 1 temporal dimension, but of 4 dimensions united in a single continuum. Every event in the universe, the birth of a star, the fall of a leaf, the thought now crossing your mind, is a point within that fabric of space-time. This vision changes everything. If time can be bent, stretched, and slowed down, then the now loses its absolute meaning. The past, the present, and the future are not moments that vanish, but fixed parts of that cosmic fabric. Everything exists simultaneously in different regions of space-time, as if the universe were a book already written, and we were simply turning its pages one by one, calling that sequential reading time. The impact of this discovery goes far beyond physics. It touches the heart of philosophy, metaphysics, and even spirituality. If time is relative, what does it mean to live? What does it mean to die? Perhaps everything that has ever happened and everything that will happen already coexist in some way on the same plane of reality, and our consciousness is merely the thread that travels through this fabric point by point, creating the sensation of movement. Einstein used to say that time is a persistent illusion, and although this phrase sounds poetic, it carries enormous scientific weight. Relativity destroyed the idea of a universal time, but at the same time gave humanity the key to understanding the cosmos with a depth never before imagined. Time is not the clock of the universe. It is the universe itself, bending, breathing, and evolving along with us. With the theory of general relativity, Albert Einstein accomplished something no one had ever dared to imagine. He transformed time into a physical dimension that curves, bends, and deforms in the presence of mass and energy. What had once been considered absolute and immutable revealed itself to be elastic, malleable, and sensitive to gravity. Time ceased to be the backdrop of the universe and became part of the very fabric of reality. To understand this revolution, one must imagine space-time as a vast elastic sheet. When a massive body, such as a planet or a star, is placed upon that sheet, it bends under its weight. This curvature is what we call gravity. And the most astonishing part, this deformation affects not only space but also time. Near massive objects, time drags, slows down, and loses its rhythm. Far from them, it hastens and flows more freely. Thus, time, which once seemed universal, proved to be profoundly local. Einstein predicted that even light would be affected by this curvature. Decades later, that prediction was confirmed when astronomers observed starlight being deflected as it passed near the Sun, as if time and space around Earth's parent star were bending. Even more precise experiments with atomic clocks aboard satellites and airplanes confirmed the same effect. The stronger the gravity, the slower time flows. Time, therefore, is a prisoner of gravity. This idea completely transformed the way we understand the universe. The clocks orbiting Earth, for instance, must be adjusted to compensate for time dilation. Without correction, the global positioning system, which guides airplanes, ships, and even your cell phone, would become inaccurate within minutes. The difference is tiny, but enough to shift the position of an entire city. Relativity is not merely an elegant theory, it is present in every journey we take and every second measured by modern technology. In extreme regions of the cosmos, the behavior of time becomes even more astonishing. Near black holes, where gravity is colossal, time practically freezes. To a distant observer, any object approaching the event horizon seems to slow infinitely, as if it would never cross it. But for the one falling in, time flows normally, until the instant they vanish forever from our perception. It is a frontier where time ceases to exist as we know it. This temporal curvature also redefines the very concept of the present. In a universe where time flows differently, according to gravitational strength, there is no universal now. Every point in the cosmos has its own temporal rhythm, determined by its speed and gravity. This means that while you listen to this narration, time does not pass equally everywhere in the universe. On more massive planets, it moves more slowly. In distant and empty regions, it accelerates. Deep down, time reveals itself as a texture of space itself. It is not separate from things, it is part of them. Every atom, every star, every galaxy slightly distorts the fabric of space-time, and that deformation defines how time passes in that location. The universe, therefore, is not a fixed stage, but a constant dance among energy, mass, space, and time. General relativity brought with it an unsettling consequence. If time can be curved, it can also form cycles, distortions, and shortcuts, the so-called wormholes. These hypothetical tunnels could connect distant points in space-time, allowing, in theory, travel from one moment to another, from one place to another, without following the straight line of linear time. At this point, physics blends with fiction, yet remains real in its mathematics. Einstein showed that time is not merely something that flows, it is something that can be shaped. This discovery paved the way for all the great theories that would follow, from modern cosmology to quantum physics, from the origin of the universe to the possibility of its end. Time ceased to be the judge of things and became one of the defendants of the cosmos itself. And the deeper we dive into this understanding, the more we realize that time, like reality itself, may be only a way for us to perceive eternity from a limited angle. If relativity showed that time can bend, thermodynamics revealed something even more enigmatic. Time has a direction. Everything in the universe seems to move from past to future, from simple to complex, from organized to chaotic. But why does time move only in one direction? Why do we never see a shattered cup reassemble itself, or a fire extinguish and then reignite spontaneously? The answer lies in one of nature's most fundamental laws, the second law of thermodynamics, and the concept that defines it, entropy. Entropy is a word that intimidates many, but at its core it is simple. It represents the degree of disorder in a system. In any natural transformation, entropy tends to increase. A glass of hot water left on a table cools until it reaches room temperature. Heat spreads, energy is distributed, and the system becomes more balanced. This process is irreversible, and that is what gives time its arrow. Entropy is the invisible engine that pushes the universe forward. In the early universe, just after the Big Bang, everything was incredibly ordered. Energy was concentrated, matter was dense and hot, and the cosmos was like a vast ocean of nearly identical particles. As the universe expanded, entropy began to grow. Galaxies, stars, and planets emerged as small islands of order within an ever-growing sea of disorder. Paradoxically, complexity, such as life, could only arise because the universe was becoming more disordered. Entropy does not only destroy, it also creates because it pushes matter to transform. What is most fascinating is that entropy gives time its sense of flow. The fundamental laws of physics, such as the equations of quantum mechanics or relativity, work equally well in either temporal direction. Nothing in them forbids time from running backward. What makes us perceive time as a continuous line is the increase of entropy. The past is the state of lesser disorder, the future of greater disorder. Thus, time, at its core, is a consequence of irreversibility. This principle manifests at every scale, from the stars that burn their nuclear fuel to the human brain that stores memories. We remember the past but not the future, because our brain is a physical system subject to entropy. The act of recording a memory increases the internal disorder of the organism, and that is what creates the psychological sense of time. In other words, the arrow of time exists not only in the universe out there, but also within us. Entropy also points to the ultimate fate of everything that exists. As the universe continues its expansion, energy becomes ever more dispersed. The stars will eventually burn out, black holes will slowly evaporate through Hawking radiation, and only a cold, cosmic silence will remain. This state is known as the heat death of the universe, a moment when all energy will be so evenly distributed that nothing else can happen. Without temperature differences, without energy flow, there will be no events, and therefore time will cease to have meaning. It is curious to think that time, so absolute in our experience, might be only a reflection of the constant struggle against disorder. Where there is structure, there is time. Where there is total equilibrium, time stops. This means that time could have a beginning, as in the Big Bang, and also an end, when the universe reaches maximum entropy. What we call eternity may paradoxically be the moment when time ceases to exist. But while the universe still pulses, time continues its march. Every heartbeat, every sunrise, every star exploding as a supernova is an expression of entropy in action. The universe lives and ages alongside us, and this cosmic slowness that transforms everything that exists is what gives meaning to existence itself. Time is not the enemy. It is the record of the process, the trace left by inevitable transformation. In the end, perhaps time exists only because perfection is impossible. The universe must disorganize itself to know itself. And we, conscious fragments of this vastness, feel time pass because we are part of this dance between order and chaos. Time is the story that entropy tells, a narrative of transformation, impermanence, and constant creation. If relativity shows that time can bend, quantum physics makes it seem to disintegrate. In the world of subatomic particles, where matter behaves as waves of probability, time loses the rigidity we perceive in daily life. It does not run in a straight line, nor does it always obey a single direction. In the quantum universe, past and future blend together, and the very concept of now becomes diffuse, almost non-existent. Time, which once appeared to be the fabric of the universe, here dissolves like mist under the gaze of consciousness. At the quantum scale, particles have no defined position or velocity until they are observed. They exist in a state of superposition, where multiple possibilities coexist. An electron, for example, can be in several places at once until someone observes it, and when measurement happens, all those possibilities collapse into a single outcome. This phenomenon, the collapse of the wave function, is one of the greatest mysteries of modern physics, and within it hides something even more unsettling, the role of the observer and its relationship to time. Before measurement, there is no past or future for the particle. It does not wait to be measured, it simply has no time. It is the act of observing that seems to create the temporal sequence. This suggests that time may not be a fundamental property of nature, but something that emerges when consciousness interacts with the universe. In other words, time may be born from observation and die when it ceases. This idea is supported by a profound question known as the problem of time. In the equations that describe the quantum universe, especially in the so-called Wheeler-DeWitt equation, which attempts to unite relativity with quantum mechanics, time simply disappears. It is not present in any of the variables. The cosmos in this view is a static state, without temporal flow. What we call the passage of time may be only an illusion created by quantum correlations within this eternal state. This means that, on a fundamental level, the universe may be timeless. What we call change might only be the result of comparing different configurations of quantum states. Just like a film reel composed of static frames that, when projected, create the illusion of movement, the quantum universe could consist of immutable states that, when experienced by consciousness, generate the feeling of time flowing. Recent experiments in quantum physics have begun to test these ideas. In laboratories, scientists have created situations in which the temporal order of events becomes undefined. For example, two photons can interact in such a way that it becomes impossible to determine which one influenced the other first. The events become literally without defined temporal order. In these cases, causality, the principle that a cause precedes its effect, ceases to exist in an absolute way. This challenges the very structure of reality as we know it. In this context, time ceases to be a line and becomes a network, a fabric of possibilities connecting in multiple directions without beginning or end. Each observer, each measurement, each act of consciousness traces a particular line within this entanglement, creating its own temporal narrative. This could explain why time can appear so different at different scales: the time of the atom, the time of the human body, the time of galaxies, all coexisting, yet without any true hierarchy. Quantum physics also raises an even more radical question. If time depends on observation, what happens in regions where there are no observers? Does the universe exist without time? And if so, what does exist mean? These questions touch the limits of human knowledge and the philosophy of mind. Perhaps time is not a feature of the universe, but a feature of consciousness itself. Physicist Carlo Rovelli, one of the leading theorists of quantum gravity, argues that time is an emergent illusion. According to him, the universe as a whole has no time. Time arises only in the relationships between parts, when change is perceived. Time, therefore, is not an isolated entity, but a reflection of interaction, a product of motion, difference, and perception. In the quantum world, time seems to oscillate between being and non-being. It exists when we observe it, disappears when we try to define it, and reappears when something changes. Perhaps time is the very act of change, and nothing more. At its core, what we call time may be only the mirror of transformation, the trace that reality leaves as it moves between the possible and the real. The theory of general relativity opened a portal to one of the strangest and most fascinating ideas ever conceived, the block universe. According to this view, past, present, and future coexist simultaneously within a single fabric of reality. Time does not flow, it simply is. Everything that has happened and everything that will happen already exists, as if the cosmos were an immense four-dimensional sculpture, and we were beings who traverse it slice by slice, believing that we are moving forward. This interpretation arises naturally from Einstein's equations. If space and time form an inseparable continuum, and if the passage of time depends on motion and gravity, then there is no universal present. One person's now can be another's past, and another's future. Each observer lives within a distinct slice of space-time, and all those slices coexist. Thus, the past does not vanish, and the future is not created. Both are already there, as real as the moment we believe we are living. Physicist Hermann Minkowski, Einstein's former teacher, was the first to express this idea clearly. From now on, space by itself and time by itself are doomed to fade away, and only a union of the two will continue to exist. In this view, the universe is not a line but a block, a vast map where all events are fixed. The sensation of time's passage would be merely the result of consciousness moving through that block, frame by frame, creating the illusion of motion, like a film slowly projected within the mind. This idea is deeply unsettling because it challenges the very notion of change. If the future already exists, then is free will merely an illusion? Are we condemned to relive the same cosmic script forever, unable to alter it? These questions permeate both physics and philosophy. Some physicists argue that in a block universe, the distinction between past and future is merely a matter of perspective. What we call change is, in fact, the way we experience an already complete structure. Modern physics reinforces this idea in several ways. When we observe a distant object in the universe, we do not see it as it is now, but as it was millions of years ago. The light from galaxies takes eons to reach us, and each photon carries a frozen memory of an instant that has passed, but still exists somewhere in space-time. The past, therefore, is not something that has disappeared. It is something that continues to exist, visible in every direction we look. The human mind, however, was not made to comprehend the universe as a whole. We exist within the timeline, not outside it. Our brain organizes experiences in sequence, creating the sense of continuity we call life. It is as if we were characters in a book who cannot step out of the pages to see the entire story at once. We live it one paragraph at a time, believing that we are advancing, when in truth we are only following a path already written. This theory also raises an existential question. If everything is already determined in space-time, what is the role of consciousness? Some philosophers and physicists suggest that consciousness is precisely what gives meaning to the static structure of the universe. Without observers, the block would be nothing but a cold, motionless geometry. It is consciousness that illuminates the slices of space-time and creates the experience of passage. The flow of time would therefore be a subjective phenomenon, a creation of the mind moving within an unchanging universe. Others, however, argue that the block universe does not imply the absence of freedom, but rather an expanded vision of reality. The future may exist, but that does not prevent us from being active participants in it. Just as all the pages of a book are already printed, but only come to life when read, the future becomes real only when we traverse it. Destiny and free will can coexist. One as structure, the other as experience. The paradox of the universal block invites us to a haunting reflection. Perhaps time does not pass. Perhaps it is we who pass through it. We are travelers in a motionless universe, sailing upon the waves of perception. The past continues to exist, the future is already there, and the present is merely the meeting point between the two. And if this is true, then time is not a river that flows, but a motionless mirror through which we move, believing we see a flow that we ourselves create. If physics tries to understand time as an objective dimension, consciousness turns it into an experience. Inside the human brain, time is not measured by clocks, but by sensations, memories, and expectations. It does not run uniformly. It stretches and contracts depending on whether we feel pleasure, pain, fear, or boredom. A minute can seem like an eternity, and an hour can pass in a breath. Psychological time is the mirror of the mind's inner state and, in many ways, is as enigmatic as cosmic time. The human brain does not perceive time directly. It constructs it. Every thought, every memory, and every anticipation are fragments of a sequence that the brain artificially organizes to make sense of reality. Science shows that the brain does not live in the absolute present. What we call now is, in fact, a small window of perception lasting only a few seconds. Everything we experience has already happened, a few milliseconds before the brain can process and integrate it as conscious experience. This delay is essential for the mind's function. It allows the brain to unify stimuli, build the sensation of continuity, and project the next instant. In other words, the brain does not live time, it predicts it. What we feel as the present is a projection, a constant calculation based on memories and probabilities. This ability to anticipate the future is what allowed us to survive as a species, but it is also what traps us in anxiety. The perception of time is also shaped by memory. The past exists only because we can recall it. Each memory is a reconstruction, not a faithful recording. When we remember, the brain rewrites the past, adapting it to the present. This means that psychological time is mutable. It is not a straight line, but a spiral that reconfigures itself according to what we feel and think. That is why time seems to pass faster as we age. The brain creates fewer novelty markers, and the days begin to blend into one another. Neuroscience has revealed that several brain regions participate in temporal perception: the prefrontal cortex, the cerebellum, the hippocampus, and the basal ganglia work in synchrony to measure intervals and organize events. But none of these systems function as an absolute clock. They create time internally, adjusting it to experience. When we are focused, time shortens. When we suffer, it drags. The mind bends time just as gravity bends space. Altered states of consciousness, such as deep meditation, religious ecstasy, or the use of psychedelic substances, also reveal how much time is a mental construction. In these states, the boundaries between past, present, and future dissolve. The individual feels outside of time, and many describe this experience as a glimpse of eternity. This suggests that subjective time is intimately tied to the structure of consciousness. When attention expands, time disappears. When it contracts, time gains weight. Modern psychology also links temporal perception to emotional state. Depressed people tend to feel time move more slowly, as if trapped in a present that will not pass. Anxiety, on the other hand, speeds up inner time, creating the sensation that the future is always arriving too fast. Time, therefore, is not only physical, it is emotional. It becomes a reflection of our pains, our hopes, and the way we relate to the world. There is also a philosophical dimension to this relationship. Consciousness is the only known entity that perceives time, and it is precisely this perception that creates the notion of self. To know that time passes is to know that one changes, ages, and is finite. Time is the mirror in which consciousness recognizes itself. Without it, there would be no identity, no history, no learning. Time is the boundary that separates us from eternity, and also what gives meaning to our passage through it. From a scientific point of view, time may not exist in an absolute sense, but from a human point of view, it is the most real substance of all. It is what we feel slipping through our fingers, what transforms everything we love, and what teaches us the value of impermanence. Time is both the stage and the mirror of the mind. and understanding this relationship may be the first step toward understanding consciousness itself. General relativity describes time as a malleable dimension that curves with gravity, and quantum mechanics shows that at the microscopic level, time behaves in an uncertain and probabilistic way. But there is a problem. These two theories, the greatest achievements of modern physics, do not fit together. When we try to apply them simultaneously, their equations conflict. Time seems to follow different rules depending on the scale at which it is observed. It is as if two kinds of time coexist: the continuous, smooth time of relativity and the discrete, fragmented time of quantum physics. Thus arises one of science's greatest questions. What is time when the universe is seen as a whole, at the point where the infinitely large and the infinitely small meet? This is where string theory and the attempts to build a unified theory of quantum gravity come in. String theory proposes that the fundamental particles of nature are not points, but tiny vibrating strings. These strings oscillate at different frequencies, and each vibration corresponds to a particle: electrons, quarks, photons, and even the hypothetical graviton, the particle that would transmit gravity. What this theory suggests is that everything that exists is in truth a cosmic symphony, composed of vibrations within a multidimensional space-time. In this view, time is not something separate from space or from the strings. It emerges as a consequence of fundamental vibrations and interactions, but at extremely small scales, near what is called the Planck length, something unimaginably smaller than a proton, the very concept of time ceases to make sense. The quantum fluctuations of space-time turn the universe into a foam of probabilities where past and future blur. Temporal sequence no longer exists in any definite way. Quantum gravity, which seeks to unite the gravitational field with the principles of quantum mechanics, leads to even more radical conclusions. According to some models, time is not a fundamental dimension, but an emergent property. It appears only when the universe reaches a certain level of complexity. Just as temperature does not exist in a single molecule, but arises from the interaction among many, time may exist only when there is collective motion, matter, and observers capable of perceiving change. The Wheeler-DeWitt equation, which attempts to describe the entire universe in quantum language, is an example of this. It does not contain the variable time anywhere. The cosmos in its purest state would be timeless, a static quantum structure, where everything that exists is eternally present. Time would arise only as an approximation, an apparent phenomenon when we look at the universe from within, not from without. To an internal observer, quantum states follow one another like a sequence, but from an absolute perspective, nothing really happens. Some physicists, such as Carlo Rovelli and Lee Smolin, suggest that time is only a way of organizing information. It is not a physical entity, but a consequence of how the universe stores and processes change. In this sense, time would be the record of the difference between successive quantum states. The past would simply be the information the universe preserves, and the future, the information not yet created. The passage of time would therefore be the flow of information through the cosmos. String theory also proposes extra dimensions beyond the four we know. In some versions, time can multiply or fold upon itself at microscopic scales, allowing the laws of physics to remain consistent. At these levels, time is neither linear nor continuous. It is granular, vibrant, almost musical. Reality behaves like a symphony of overlapping frequencies that interfere and create the illusion of sequence. These hypotheses profoundly challenge our intuition. If time is not fundamental, then everything we know, memory, aging, causality, would be merely an emergent phenomenon. The question then changes: does time exist because the universe changes, or does the universe change because time exists? Perhaps the very act of perceiving a difference between two states is what creates time. It would not be the backdrop of change, but its result. At the ultimate limit, where space-time curves to infinity, inside black holes or in the first instance after the birth of the cosmos, time ceases to exist as we know it. It folds, mixes, and vanishes. What remains is a sea of pure possibilities where everything is simultaneous. And perhaps it is from this ocean of timelessness that the universe was born, and to which it will one day return. Thinking about the before of time is a contradiction. The very act of imagining a before presupposes the existence of time. Yet this is one of the most intriguing questions in cosmology. What existed before the Big Bang? Did the universe have a beginning, or has it always existed in some form? The problem is that if time began along with the universe, there can be no before. The origin of the cosmos also marks the origin of time itself, and this profoundly challenges human logic. According to the standard cosmological model, the universe was born more than 13 billion years ago in an event known as the Big Bang. But that name, although popular, is misleading. The Big Bang was not an explosion occurring within space and time. It was the emergence of space and time themselves. The universe did not expand outward from something. It began expanding from itself. It is as if the fabric of space-time sprouted from nothing, carrying with it the laws of physics, matter, energy, and the flow of time. Stephen Hawking was one of the scientists most devoted to understanding this boundary. In his proposal of imaginary time, he suggested that in the universe's earliest moments, time might have behaved like a spatial dimension. This would mean that before a certain point, there was no distinction between past and future. Time was a curved direction, not a line. When the universe cooled, time began to flow as we know it, creating the sensation of a beginning. Thus, the Big Bang would not be the birth of something from nothing, but a transition from a timeless state to a temporal one. This idea is difficult to visualize because the human mind depends on time to think. Our thoughts, memories, and language are structured in sequence. Asking what existed before time is like asking what lies north of the North Pole. The question loses meaning because there is no north beyond that point. Likewise, the Big Bang did not occur at a moment in time. It was the emergence of time itself. Even so, cosmologists attempt to go beyond that boundary. Some models suggest that our current universe may have been born from a previous cycle, an eternal collapse and rebirth, a cosmos that contracts and expands in infinite successions. This hypothesis, known as the oscillating universe or Big Bounce, proposes that time has no absolute beginning but an eternal rhythm of cosmic pulsations. Each cycle would destroy the previous one and give rise to a new one, a kind of breathing of the universe itself. Other theorists, such as those exploring the idea of eternal inflation, suggest that our universe is merely a bubble within a much larger multiverse. In this scenario, new regions of space-time are constantly being born elsewhere, each with its own physical laws and temporal flows. Time could be something local, confined to each universe, rather than a universal entity. What we call the beginning may simply be an edge within an infinite ocean of parallel existences. But there is an even deeper view. Perhaps time has no point of origin because it never began. It is an emergent illusion that appears only when the universe acquires form and structure. In the most primordial state, when there were no particles, fields, or observers, time made no sense. Only when relationships between things arise, when one change can be compared to another, does the concept of before and after come into existence. Time, therefore, may be a byproduct of complexity. This hypothesis resonates with quantum physics. At the most fundamental level, the universe can be described by an eternal wave function, a static state containing all possibilities of existence. Time emerges when parts of this state interact, exchanging energy and information. Thus, time did not exist before the Big Bang because there was no differentiation, only a totality without contrast, without cause, without sequence. The birth of time is, in this sense, the birth of difference. When the universe began to expand, temperature dropped, entropy increased, and distinctions arose. Temporal flow emerged from imbalance, from the contrast between what was and what became. From that instant, history began to be written, a story that extends to this very moment as you listen to these words. In the end, perhaps time has no beginning because the universe itself is the beginning. And perhaps what we call the before of time is merely the absolute silence of a cosmos that had not yet learned to tell its own story. Among all the phenomena in the cosmos, none challenges our understanding of time as profoundly as black holes. They are regions of space where gravity is so intense that nothing, not even light, can escape. They are the ultimate frontiers of physics, places where space and time stop behaving as we know them. Inside them, the known laws of nature collapse and time literally unravels. A black hole is born when a star of colossal mass reaches the end of its life. After burning all of its nuclear fuel, The internal pressure that sustained the star gives way, and gravity wins. Matter collapses in on itself, compressing down to a point of infinite density known as a singularity. Around this singularity forms the so-called event horizon, the boundary beyond which nothing can return. It is there that time begins to distort in an extreme way. For a distant observer, any object approaching the event horizon appears to slow down. The light it emits becomes weaker and redder until it disappears completely. It is as if the object were frozen in time, trapped at the edge of the abyss. However, for the one who is falling, time flows normally until the moment they cross the horizon and space bends to the point that every possible direction leads inevitably toward the singularity. Time and space trade roles. What once could be escaped becomes inevitable. This transformation is one of the strangest consequences of general relativity. Near a black hole, time does not merely slow down. It curves, folds, and fragments. If we could somehow survive the fall, we would see the entire universe accelerate before our eyes. External time would race faster and faster, while our own time would drag. In just a few internal seconds, we might watch billions of years of cosmic future unfold outside. But black holes also guard one of the greatest paradoxes in modern science, the information paradox. According to quantum physics, no information can be destroyed. Yet everything that falls into a black hole seems to vanish forever. This would create a fundamental violation of the laws of nature. Stephen Hawking brought this dilemma to the center of debate. He proposed that black holes are not completely black, but emit a very faint radiation, Hawking radiation, caused by quantum effects at the event horizon. This radiation implies that black holes can slowly evaporate. However, if they disappear, where does the information they contained go? That question still has no definitive answer. Some theories suggest that the information is encoded on the surface of the horizon itself, in a kind of cosmic hologram, which led to the development of the holographic principle, the idea that all the content of a volume of space can be described by information on its boundary. This would radically change our notion of time and reality, suggesting that the universe may, in some sense, be a projection of deeper dimensions. Black holes, therefore, are not just astrophysical objects. They are natural laboratories for testing the limits of time. Inside them, time can stop, disappear, or even reverse, according to what the equations suggest. For an observer falling beyond the horizon, there is no return, and there is no true future or past. Everything collapses into a single point where time ceases to exist. From a philosophical point of view, black holes are the perfect metaphor for the mystery of existence. They are regions where time dies, but the universe continues. What happens inside them remains inaccessible, perhaps forever. It is as if the cosmos were hiding within these abysses the secrets of its own birth and its own end. And there is an even deeper hypothesis. Some physicists believe that the interior of a black hole may contain the embryo of another universe. This would mean that what we perceive as the end of time in one cosmos could be the beginning of time in another. Time then would not be linear or finite, but a cycle of cosmic rebirths. The collapse of a star into a black hole could generate in another dimension the Big Bang of a new universe. Black holes force us to confront a disconcerting truth. Time, at its deepest level, is fragile. It bends, shatters, and can vanish. But it is precisely at these edges of the impossible that science finds traces of eternity. For where time ends, perhaps something begins that we do not yet know how to name, something that for now we can only call mystery. If time can bend, slow down, and even distort, an inevitable question arises. Would it be possible to travel through it? Einstein's relativity opened the door to that possibility, at least in theory. In curved space-time, certain trajectories could take a traveler back to their own past, or project them into the distant future. And although the idea seems to belong to science fiction, it is born from the very laws of physics. According to general relativity, time is affected both by gravity and by speed. A traveler moving at speeds close to that of light would experience time much more slowly than those who remained still. Thus, it is perfectly possible, from a physical point of view, to travel into the future. One simply needs to move fast enough. This phenomenon, called time dilation, has already been confirmed in experiments with subatomic particles and atomic clocks. The difficulty is technological. Achieving such extreme velocities is still far beyond our capabilities. But what about traveling to the past? That is where the paradox begins. The very structure of space-time allows for solutions known as closed time-like curves, trajectories that bend back on themselves, linking the future to the past. These solutions naturally appear in Einstein's equations in specific scenarios, such as around rotating black holes or within the so-called wormholes. These theoretical tunnels could connect two distant points in the universe, allowing one to cross space and time in a single leap. Physics, however, is unforgiving to those who attempt to defy causality. If someone were to go back in time, they could interfere with events that led to their own existence, creating the famous grandfather paradox. What if you traveled back and prevented the birth of one of your ancestors? How could you then exist to make that journey? Logic collapses, and with it the linear notion of cause and effect. Several theories attempt to resolve this dilemma. One of them is Novikov's self-consistency principle, which proposes that the universe would prevent any action capable of generating contradiction. In other words, even if someone traveled to the past, they could not alter events in a way that created inconsistency. The traveler's actions would already be part of the very past they were trying to change. Time would be like a tapestry already woven, and every thread, even the rebellious one, would reinforce the final pattern. Another hypothesis is that of parallel universes. According to this idea, going back to the past would not change one's own universe, but would create a new timeline, a branching of space-time. The traveler, by interfering in the past, would generate a new reality that coexists with the original. This concept aligns with quantum mechanics, especially the many worlds interpretation, where every decision creates a cosmic bifurcation. Thus, each time travel would, in fact, be a transition between distinct universes. But perhaps the deepest explanation lies at the very limit of what we call time. It may be that the past and future do not exist as places to be visited, but as fixed dimensions within a universal block. In this view, traveling through time would not mean moving along a path, but shifting perspective within an unchanging structure. The past would remain eternally preserved, and the future eternally defined, yet both inaccessible, like scenes trapped in a finished film. There is also a practical obstacle that makes time travel nearly impossible. The energy required to create or stabilize a wormhole would be colossal. Moreover, any quantum fluctuation could cause it to collapse instantly. Even if it could be opened, the simple act of crossing it would generate radiation and gravity strong enough to destroy it. Thus, time seems to protect its secrets, as if the universe itself prevented us from tampering with its causal line. And yet, quantum physics continues to challenge that barrier. Some experiments with subatomic particles suggest that quantum effects can act retroactively, influencing the immediate past. Phenomena of quantum entanglement, in which two distant particles seem to share the same state instantaneously, defy our notion of time and distance. It is as if reality in its essence were timeless, and the temporal flow we perceive were merely a projection. Time travel, therefore, may never exist as we imagine, with machines full of levers and glowing panels capable of taking us into the past. But in another sense, it already exists. Every memory is a journey to what once was. Every dream is a passage to what has not yet come. The human mind is perhaps the universe's first time travel device, capable of crossing time without ever moving through space. If time had a beginning, it can also have an end. Modern cosmology seeks to understand not only how the universe began, but how it will end, and what will happen to time when that end arrives. The future of the cosmos is as much a physical question as a philosophical one, and the possible answers are as vast as space itself. Time, after all, is not just the stage of existence, but the very protagonist of its story. According to what we know today, the universe has been expanding since the Big Bang. This expansion is not slowing down, it is accelerating. The cause of this acceleration is attributed to something mysterious called dark energy, an invisible force that seems to fill all of space and push galaxies away from one another. If this trend continues, the universe's fate may lead to a scenario known as the Sex, Big Freeze Maus, or heat death. In that future, galaxies would drift so far apart that the night sky would become completely dark. The stars would burn all their fuel, turning into white dwarfs and then into cold spheres of degenerate matter. Black holes, which today seem eternal, would also slowly evaporate through Hawking radiation, and when all energy becomes evenly distributed, time itself would lose meaning. Without motion, without difference, without change, the universe would become a silent ocean of inert particles, where nothing happens anymore. Time would die along with the last flicker of light. But this is not the only possible ending. In another scenario called the Tau Big Crunch, expansion could one day reverse. Gravity, overpowering dark energy, would cause the universe to collapse back upon itself, returning to a dense, hot state similar to the original Big Bang. In this case, time, instead of extinguishing, could restart. The end and the beginning would be the same, like the breath of a cyclic cosmos eternally reborn from itself. There is also a third, even more unsettling hypothesis, the Big Rip. If dark energy continues to accelerate the expansion at increasingly faster rates, it could tear apart the very fabric of space-time. First, galaxies would separate, then solar systems. Later, planets and even atoms would be destroyed. Time would stop flowing because space itself would cease to exist. It would be the absolute end, the instant when the structure of reality unravels. Regardless of the scenario, all predictions converge on one conclusion. Time is not eternal. It was born, and in some way it will end. And paradoxically, it is that finitude that makes time so precious. If the universe lasted forever, nothing would matter. The passage of time is what gives weight to existence. Time is the measure of meaning, and the end of time is the final punctuation of every possible story. Cosmologists also consider a fascinating idea that time may continue to exist even after the end of the universe. In some versions of quantum gravity theory, the total collapse of matter and energy could give rise to a new space-time, a cosmic rebirth. Each universe would be a single cell within an infinite tree of realities, each with its own time. What we call the end would be only a transition, the beginning of another timeline in another realm of being. These ideas lead us to an even deeper question. Is time a property of the universe, or is the universe a manifestation of time? Perhaps time is the true creator, the invisible force that generates, transforms, and dissolves all that exists. If space is the body of the cosmos, time is its soul. The final destiny of time remains unknown, but the fact that it moves towards something is what allows us to exist. We are, in essence, fragments of time aware of its own passage. And perhaps the greatest mystery is not the end of the universe, but the miracle of being here, living in this fleeting instant between what was and what will be. Among all the dimensions of the universe, time is the only one that carries the weight of the soul. It is the mirror of existence, the invisible thread that connects birth, memory, and death. Unlike stars and galaxies, which follow cosmic rhythms that last millions of years, human beings live within a fragile, delicate, and finite temporal scale. It is in this contrast between the eternity of the cosmos and the brevity of life that the drama of consciousness arises, knowing that time passes and that we pass with it. Since the dawn of civilization, humanity has tried to conquer time. We built monuments to resist oblivion, wrote books, carved stones, and invented art, all to leave marks upon the fabric of history. In every act of creation lies the silent desire to remain. Time, while it ages us, also grants us the chance to leave behind something that transcends it. This duality defines the human condition, to exist while knowing that everything is transient. Time shapes our bodies and our emotions. It is the invisible architect of wrinkles, memories, and losses. Every cell that renews itself, every thought that transforms, every love that is born and fades, are manifestations of temporal flow within us. We are made of time. Our atoms were forged in ancient stars, and what now pulses through our veins is the result of billions of years of cosmic history. When time acts upon the universe, it creates. When it acts upon human beings, it teaches. The awareness of time's passage is both a gift and a curse. It gives us purpose, but it also gives us fear. Knowing that life is limited forces us to choose, to act, to love with urgency. Without time, there would be no meaning, only stillness. Time gives flavor to existence, turning every moment into something unique. Yet it is also what makes us feel the pain of loss, the nostalgia for what once was, and the anxiety for what has yet to come. Awareness of time is the price of lucidity. Throughout history, humanity has sought to overcome this condition. We have searched for immortality in religion, technology, science, and myth. We dream of stopping time, freezing the moment, reversing aging, reliving the past. But perhaps the secret is not to fight against time, but to learn to dwell within it. Time is not the enemy, it is the teacher. It takes nothing from us, it only transforms. What we call the end is often merely a change of form. From a philosophical point of view, the relationship between time and the human being is the deepest point of the experience of being alive. Without time, there would be no self, for the self is a continuity that recognizes itself through change. Identity is a narrative, and every narrative needs time. We live by telling stories, the story of what we were, what we are, and what we wish to become. And it is this ability to tell time that distinguishes us from all other forms of life. Even knowing that everything is ephemeral, we seek eternity in small things, in the smile of those we love, in the beauty of a starry night, in the memory of a simple moment that remains forever engraved within us. Time may destroy everything, except the meaning we give to our experiences. And perhaps the meaning of life is precisely that, to create meaning before time takes it away. There is also a spiritual dimension to this relationship. Many ancient traditions saw time as a cycle, not an enemy but a flow of rebirth. Death was not the end but a change of state, a return to the source. Time, in this vision, is not a line that ends, but a circle that renews itself. Nature itself teaches us this. The seasons return, seeds die to bloom again, and night always yields to day. Time does not destroy, it transforms everything so that nothing remains still. In the end, perhaps the greatest mystery of time is not its origin or its end, but the way it makes us feel alive. It reminds us that everything is impermanent, and precisely because of that, precious. Without the passage of time, nothing would have value. Love only matters because it can end. Youth is beautiful because it is brief. Life is intense because one day it will cease. Time teaches us to see infinity within the instant. We live in an era in which time seems to have accelerated. The technological revolution has transformed not only the way we work, communicate, and consume information, but also the way we perceive time. The clock that once marked the days, the hours, and the pauses has been replaced by a continuous stream of notifications, messages, and stimuli. Digital time has no silence, no emptiness. It rushes forward at high speed, dragging along the human mind that tries to keep up, but rarely succeeds. In the past, time was linked to natural cycles. Sunrise, nightfall, the seasons, the body's rhythm. Today it is tied to the glow of screens, to algorithms and deadlines. Dawn has lost its meaning before the constant light of devices. Work and leisure have blended together. Rest has become a challenge. We have never been so connected, and paradoxically so distant from real time. Digital time is instantaneous, fragmented, and often impersonal. Neuroscience shows that this new relationship with time is altering the structure of human attention. The brain, exposed to rapid and intermittent stimuli, adapts to immediate rewards and loses the ability to sustain focus for long periods. This creates a distorted perception. We feel that time passes faster, yet we also feel that there is never enough of it. The result is a state of chronic acceleration, a constant feeling of delay, urgency, of always chasing something that time itself prevents us from reaching. The paradox is cruel. Technology was created to save time, but it ended up making us lose it. The minutes we gained in efficiency, we lost in presence. Speed promised us freedom, but trapped us in a cycle of repetition. With every tap, every update, the mind fragments into small shards of attention. The experience of time ceases to be linear and becomes a sequence of short, disconnected impulses in which the past fades and the future never arrives. Social networks are the clearest mirror of this temporal mutation. They operate in a continuous present, an eternal now that leaves no room for silence or reflection. The timeline, an ironic name, is not a line, but a whirlwind. Information appears and vanishes within seconds, leaving no memory behind. Digital time is in essence disposable. It replaces depth with quantity, rhythm with haste, content with reaction. This acceleration has also affected how we inhabit our bodies. Biological time, slow and organic, has entered into conflict with technological time. We sleep less, breathe poorly, eat in haste. The body, still obedient to natural laws, struggles to keep up with the pace of machines. This disconnection between human time and digital time generates fatigue, anxiety, and emptiness. We feel that time passes too quickly, yet at the same time we feel that nothing truly happens. Contemporary psychology calls this phenomenon chronic presentism. We live trapped in a continuous present, unable to anchor ourselves in the past or project ourselves into the future. Time has lost its boundaries. There is no more waiting, no anticipation, only updating. That is why anxiety is the ailment of the digital age. It is the symptom of a mind that has lost its natural rhythm of time. Yet not all is lost. The same technology that distorts time can also help us reconnect with it. Guided meditation, the sounds of nature, recordings of white noise and relaxation videos, like the one you are listening to now, are attempts to restore our lost relationship with inner time. They are invitations to slow down, to breathe, and to regain control over our own perception of time. Perhaps the great challenge of the 21st century is not to master time, but to relearn it, to find balance between digital urgency and biological silence, to rediscover the value of slowness in a world that confuses haste with progress. Human time is not made of algorithms. It is made of heartbeats, of pauses, and of presence. In the end, every second we live is a fragment of the infinite. Digital time may deceive us, but real time is still here, in the sound of the wind, in calm breathing, in the simple act of existing. All it takes is to stop even for a moment, and time begins to breathe with us. There is a question that haunts both physicists and philosophers. Can time end? What if it is only a transitory phase of the universe, destined to disappear like so many other emergent properties of reality? This idea, as impossible as it may seem, is taken seriously by some of the greatest thinkers in contemporary physics. According to them, time may not be a permanent feature of the cosmos, but a temporary phenomenon, a structure that arose, evolved, and at some distant point will cease to exist. In many theories of fundamental physics, especially those that try to unify gravity and quantum mechanics, time does not appear in the equations. This means it may not be something fundamental, but rather a consequence of interactions between the parts of the universe. Just as temperature does not exist in a single molecule, but emerges from the collective behavior of many, time could be the result of matter and energy interacting on a cosmic scale. When the universe disperses completely, time will cease to have meaning. Carlo Rovelli, one of the leading theorists of loop quantum gravity, argues that time is an emergent illusion. For him, the universe as a whole is a timeless system, and what we call the passage of time is merely the change in correlations between different parts of reality. When there are no more differences, when everything reaches perfect thermal equilibrium, time will simply cease to exist. This cosmic balance point is what physicists call the heat death of the universe. But there are even bolder hypotheses. Some physicists believe that time could reverse its direction when the universe reaches extreme energy states. If entropy were to reverse on cosmological scales, time could begin to run backward. This would not mean reliving the past, but rather that the very concepts of past and future would lose meaning. The universe could collapse upon itself and emerge in another temporal direction, an infinite sequence of births and extinctions with no true beginning or end. Other theories suggest that time is merely an illusion created by consciousness. If the universe in its deepest form is a timeless block of space-time, a geometric structure where all events coexist, then time would be nothing more than a mode of perception. What we call passage is not the motion of the universe, but the movement of our mind, turning through its pages. Time would die not when the universe ends, but when there is no longer consciousness to perceive it. Stephen Hawking even considered that time could be a dimension that changes its nature at the boundaries of the cosmos. Under extreme conditions, such as in singularities or the first moments after the Big Bang, time might behave like space, not flowing, but coexisting in all directions. This would mean that time, in its linear sense, is only a local property, restricted to certain regions of the universe. Beyond them, time would not exist. There is also a more philosophical and unsettling interpretation. Time does not exist because it never existed. What we call time may simply be the human way of organizing the unknown. The mind, unable to grasp the totality of reality all at once, divides the universe into before and after, cause and effect, beginning and end. Time then would be the map of a reality that is, in essence, simultaneous. If time truly ends, what will remain? Perhaps nothing, or perhaps everything. In a universe without time, there is no change but also no loss. There is no future but also no past. Being and non-being become indistinguishable. It is a concept that transcends reason and approaches what mystical traditions have always intuited, the idea of eternity not as infinite duration, but as the total absence of time. This possibility forces us to re-evaluate our own existence. Everything we are, memories, desires, emotions, depends on the flow of time. If it ceases, what happens to the self? Perhaps consciousness, like the universe, is only a temporary form of eternity perceiving itself. And when time ends, what we call life may simply return to the original silence from which everything was born. Time is the great paradox of existence. It is at once the prison and the freedom of everything that lives. Without it, nothing could change, but because of it, nothing can remain. Time creates and destroys, unites and separates, gives meaning and takes it away. It is the invisible artist who sculpts the universe, and with the same touch that gives birth to a star, erases everything it illuminates. If time is an illusion, as so many physicists and philosophers suggest, then it is the most perfect of illusions, the one without which reality would lose its meaning. We live within this illusion like fish in water, unaware of the medium that sustains us. Time is what makes the past exist in memory, the present pulse in consciousness, and the future shine as a promise. It is the thread that stitches the fabric of experience, linking all that we are to what we were and to what we may yet become. Even if the universe in its deepest structure is timeless, we are not. We are temporal creatures, made of moments, shaped by their passing. And perhaps that is exactly what makes us human. There is something profoundly beautiful in accepting time as a mystery, because even without understanding it, we learn to feel it. We measure time with clocks, but also with tears, laughter, silences, and heartbeats. It is the pulse of the cosmos, but also the rhythm of the heart. When we love, time expands. When we suffer, it drags. When we contemplate, it stops. No theory, however sophisticated, can capture this intimate and subjective dimension of temporal experience. If time is not real, then every moment is eternal. Nothing is lost. It merely changes form. The past still exists somewhere within the fabric of space-time. The future is already written, and the present is the point of contact between them. To live is to cross that frontier moment after moment, aware of both our finitude and the eternity that surrounds us. Time does not flow outside of us. It flows through us. Physics shows us that time can be relative, elastic, and even emergent. But life shows us that it is precious. Time is the most valuable currency in the universe because it cannot be stored or regained. All we have is the now, that tiny interval between what was and what will be. It is within this sacred space that creation, love, and meaning dwell. Perhaps the secret is not to try to master time, but to inhabit it fully. When we gaze at the night sky, we are looking into the past. The stars we see may no longer exist, and yet their light travels through time to reach our eyes. This means that in a way nothing ever truly disappears. The universe keeps everything, even what we believe to be lost. So it is with life. What we have lived continues to echo, in memories, in gestures, in invisible marks left upon the world. In the end, time may be an illusion, but it is a necessary one. It is what allows us to love, to learn, to grow, and to exist. And even if the universe one day falls silent and time ceases to flow, the experience we had of it will remain real, because it was felt. And to feel is the deepest form of existence. Time has always been with us, as a companion, a teacher, a mystery. It shapes us from the first breath of life to the last sigh, and perhaps beyond. Every second is a fragment of eternity, a particle of existence that will never repeat itself. To understand time is to try to understand the very act of existing, and perhaps that is why it remains beyond our grasp. Because time is not something to be understood, it is something to be lived. As you listen to these words, Time continues to move silently around you. It flows in the sound of the rain, in the beating of the heart, in the distant glow of the stars sending their light across the centuries. And within this flow we find beauty, in the certainty that everything passes, yet nothing is truly lost. Time transforms, recycles, reinvents. It is the invisible cycle of creation, the same one that brought us here, and that one day will carry us forward. Perhaps time does not exist in the way we imagine. Perhaps it is only the perception of an eternal universe discovering itself. But while we are here, within this line of moments, time is our reality. It is within time that we love, suffer, learn, and leave our marks. Time is our mirror. When we look into it, we see what we are, brief beings, yet aware of our own brevity. And it is this awareness that gives meaning to existence. That is why, more than understanding time, we must feel it. Feel it in the pause between one thought and the next, in the space between one breath and another, in the gaze of the one beside us. Time is what turns the present into eternity, and what transforms the fleeting into something sacred. So as this journey ends, close your eyes for a moment. Breathe. Notice the silence. This is the point where time meets eternity. This is the instant that truly exists, the present, and within it lies everything, the past that shaped it and the future that will be born from it. Comment where you are listening from, share this video with someone you love, and subscribe to the Dormindo Consciencia channel to continue exploring the great mysteries of the universe. Because as long as time exists, and even after it falls silent, there will still be questions, there will still be curiosity, there will still be consciousness, and above all, there will still be the desire to understand why time, though invisible, is what makes everything exist. Sweet dreams, and see you in the next video.